Hey guys, welcome back to another episode on the Defender build. So this week we are looking down the path of laying down some new chassis rails. We've got our new mounts coming off that, and we've already gone through and pre-assembled all of the Defender rear trailing arms that we did in the previous episode. So what we're looking at doing now is pretty well forming up these brackets on the chassis plates, and we will pre-weld them out on here so they're Mickey Mouse. And then we'll go through and put them up on the actual side of the chassis, and that will give us a good base to start shooting our links off. So we're looking at about 5 degrees either side of this to pretty much give us a little bit of outwards pinning on the diff, and then obviously our 4-link on the inner will pick up the rest of that to keep that diff pinned and triangulated and stop any kind of parallel movement in the back or walking. So where we're at is pretty well the design that we showed in the last episode was keywaying and building off a pretty stout bracket. Now this is sort of where we're at. This is a big bracket, but they are big arms, and the amount of leverage on them needs to have something sturdy. So this is all interlocking design, and at the moment the only thing holding this together is a bolt in the middle. Now let's talk about the center section. As you can see here, this middle section is a spacer for a weld out procedure of the actual arm. And what you'll basically see is generally normally about 1 mil over or 0.5 of a mil over. So if we have a stack height of like 66.5 or 67, this is probably going to be that 67.5, 68. Now this helps with contraction processes and stuff like that. So once you do weld this out, it is going to contract. You can mitigate that a bit by welding, outside and pulling it and then contracting it in, stuff like that. But we don't need to do that. We can just set it nice and build from that. Have a good nice standard there before we even have to stuff around with pressing stuff. Now, like I said, we've got that in there, and then we've got 2 spaces in here which help with the diagonal access or roll of the actual anti-wobble in there. Now that won't experience a great deal because of the way it is made and what it is to combat, but I just like leaving provisional stuff in certain ways instead of having it knock up or hard up against this plate and dig into it. No need to do that when we can mitigate that issue. As this goes on the chassis, we do have this chopped down to suit that shank of this bolt, and that shank goes all the way through these plates and only has a thread kick out here. And that helps with elongation factors. Now the 2 spaces we've got in here are 10.5 mil each. Which gives a combined 20 mil height added onto our 67, 68 mil width there. And basically, it's gone through and formed all this up. Now, in terms of the finish of what you're looking at now, this is like a 300, 350 MPa plate, 4 mil brackets, 6 mil brackets, 4 mil chassis plates. And basically, I go through and pretty meticulously clean these. Now, I like it because of the welding. It's nice and clean. You're not fighting mil scale. When you go to hit that first weld, depending on your welder, if you've got hot starts and all that kind of stuff, but when you go to hit that first weld, you'll notice you get that and it's like sort of splattering, and it's a bit cold, the toe on it and everything like that. So with this, boom, straight up, just nice clean welds, and that's what we're here about. So I go through and I either treat these in some form of acid base and then neutralize it to remove the mil scale. And generally that only works in the actual small bracketries. When it comes to the big girls, I normally have to go through and hit that with a strip disc. And a strip disc is very good, but they are expensive, and they normally start between depending on the pricing and the brands you're going for, but normally around that $25 to $40 up for a disc. And I could tell you if you were to do one side of these plates, you're probably looking at 2 discs just to do one side of these plates. So very expensive, but once we go to put this on the chassis, it gives us that really nice area to weld out stuff like our hydros and everything. Then I go through DA it, 40 grit. Sometimes I'll hit it with 240 grit, depends on what the look is and what it's going to do. But most of this stuff's just all 40 grit, and that's all we sort of need. So where we're at now is pretty well going to go through and tack this with the TIG welder. Reason for the TIG welder, I'm not going to weld it out with a TIG, but we'll tack it with the TIG because it only puts small little tacks in there. Now, when you do it with the MIG weld and you start to go through this, you leave these big sort of BBs in there, and when you go to weld, you'll get your weld sort of change as it goes past. That's just small little particular things that I look for when I'm doing stuff. To most people, they wouldn't even care about that, but you know, there's a difference between quality and quantity and getting it done and taking your time. So that all comes into play. Now what we're going to go do is basically form all this up, go through, weld it out, and we'll talk through it as we go throughout the actual procedure of it. Righto, let's set up the TIG. So we're only looking to do a bit of tacking. I currently got a 12 cup on here, 2.4 fluoriated tungsten, which is a red tip, and then we got the 17 torch. Previous episode you would have seen I sheared this off here just from basically heat abuse over the years and, you know, really putting some bad angles. They're only good for a couple of years and then they start to diminish. So new one on that. The reason why I like these torches is because they're micro, tiny, and when it comes to, you know, dexterity and stuff like that, like exhaust welding or small little stuff, I tend to find this doesn't drag or ruin the welds because it's so lightweight, whereas you get those ones with the big swivel balls on the end, they tend to drag and sort of fighting the resistance of that behind you. Anyway, so that's that, probably about 25 CFM on the argon, and then now let's set up the welder. So DC, we'll go through a couple of settings. You basically got your, you know, pyramid here of settings from start to finish. We'll go all the way to the start. Now we are going to be pre-gas. I'm not doing chromo, so that's fine on 1 second. Start amps, probably go down to like say 120. Gas between peak amps, 1 second, is pretty fine there. Amps, so probably about that 160, 170. I don't use a foot pedal, so I'd say we don't want to go crazy on this and melt anyway. I'll melt the edges off the 6mm, so let's go 160 for that. See how that goes. Gas between on ramp down. Finish amps, take that down to about 100. Post gas, we're only doing mild steel, so push that down to maybe about 5. It's pretty excessive still, but that will do. And our tungsten selection, we're going to go back down to a 2.4. The 3.2 was when I was using it on the trailing arms, and I didn't want to keep ruining the actual form of the tungsten at the end. So that's pretty much us set up to go through and tack up now. Rods I use, ERS 70-6, and pretty robust for very dissimilar kind of metals. When you push to like a 80D2 or something like that, you'll have to normalize the steel and stuff like that with heat treating, so like chromo. So generally most people use the -6. Only problem is the silica compound, and it does make the weld like to wander, and you won't get those real nice fat blobs of tacks unless you do pedal pump. Some people can do it. Some people, you know, just starts to wander around like a fish, and basically your welds don't, you know, tie in super nice on the toes. Anyway, like I said, gas, we're about that 25 CFM. Where are we? Yeah, about that locked in. So we'll go in here now and go through and form up our tack. So like I was saying, that fitment there, pretty damn juicy. We'll go through, lay some tacks in here, probably go base first and then come up to where we're going to do some heavy tacks in here and make sure that we're still good with the amount and everything. Get both of these heavily tacked up and everything like that, and we'll probably look at picking the ones off the chassis that we're on here now, knock them off quickly, and then we'll pretty much mark them up just so we get a rough idea where they were sitting, and then put these mounts underneath the chassis here. One thing, I probably will have to lift the cab up a little bit, just because we do have to try and get a weld in here where the body actually does come down, but that shouldn't be too bad. So we'll go through and tack these out. So at the moment, I'm looking pretty good. I'm basically just going to get one on the top section here. And then before I go to this back section here, we do want to pull in the taper off so that we don't have that out too much, and then form that there with a tack. At the moment, we are, like, I haven't even done anything on this at all. This is just sitting in its natural state. But you can see how straight that is just from basically doing keyway alignment and stuff like that. Super happy about that. So We'll smack a big old tack on the front of that. Probably need a little bit more poke out. Now, you can afford to have poke out with these bigger cups, obviously with the amount of CFM you're pumping from it. If you're someone that's not super familiar with these and you are using traditional style cups like an 8 or something like that, you can only get so much poke out because of the amount of turbulent gas coming out, won't cover it. Then you expose it to atmosphere and your tungsten will start getting tarnished, and the list goes on with issues. So, hey, no earth. Even though I'm standing on it, yeah, chuck a good old earth on that. Goes to show you, sometimes doesn't matter how much you're prepared. So you can see the contraction straight up there. Now, I probably could hold this a little bit with a, what do you call it? G-clamp or something like that. We might pull this out a bit so that we can get under it. It's a pretty big plate, this thing. So where are we? We want to be on top like that. And this is the only problem with using TIGs and stuff like that, is that if you haven't got free hands, you're going to struggle to tack up. But as you can see, I got these little nooks that we were talking about, and they do help with just blending with no filler rod. You can see how easy that was. I didn't even have any filler rod, it just blended that straight in. Happy days. We're looking pretty good here. I'm just going to get the old 150 ruler, which works well when you're doing fit up on this kind of stuff. Sort of work it around like that, get that back underneath there, which gets us that there. I'll pull that out now. That should hold us where we want. Now, I'm not using gloves at the moment because I'm not really subjecting myself to any kind of heat near my fingers, nor am I having to weld anything long distance. I just like to hold it for dexterity at the moment until we do finalize things. So we've got our top little plate here, which I reckon we can probably lay a back tack on that. So we're looking at a separation here of around, say 10 mil down here, 10 mil, that looks pretty good. Go through, chuck some filler on the bottom side of this. Actually, we'll go midpoint because we'll probably pull these in clamps because they will contract a little bit. Happy days. And still holding down pretty nice there. That one's pretty good. Get one up on this top section. And we do have the bolt in there, which is holding that nice and parallel to where we need to be. Get one on this side. A bit of an uncommon thing when it comes to the four-wheel drive industry these days is honestly TIG welding stuff on cars. When it comes to automotive, like Japanese cars and stuff, a lot of people are already, you know, in that field these days, but a lot of people don't do TIG welding yet when it comes to cars, or four-wheel drives, I should say, sorry. So what we're going to do here is get a clamp and probably start to pull some things down, just because obviously we're locking stuff in now. And once we get all these tacked up and everything, we'll get to the welding stage, and we'll set up the MIG, and I'll show you some stuff through that. So we're up to the point now of MIGging. Basically, I've gone through, just sort of done a quick little run here. Did a practice run. using a different wire these days, and I really do enjoy it. It does burn very clean and crisp. A lot of the wires you do get from like Bunnings, Toolex and all that kind of stuff, it's doable and usable kind of shit, but it just doesn't burn clean. It, you know, has powdery shit everywhere and stuff like that. The one I like to use is this Lincoln. It's the Ultramag stuff, I believe it's called. Yeah, Ultramag S6. It's the next step up from the lower spec Powercraft crap. This stuff here, it's probably about 20 to 30% dearer. Sadly, I didn't have a 15 kilo roll for the 250 MIG, so I had to chuck a 5 in, but that would be plenty for what we're doing on here. It just burns better, it's a nicer weld, and it doesn't have so much splatter. Pretty well gone through, tacked a big plate on the bottom of this because I am going to weld this on here now before we put it on the car. May as well do nice welds in this kind of form. Yes, we can do it under the car, but it's just positional. And trying to, you know, sit up and fatigue your back and all that kind of stuff. Just work smarter basically these days. So we are set up now to go through and weld. I'll talk through a couple of little things. Now, a common look of the weld that is there, a misconception is that obviously a lot of people pull, and that's a pretty generic thing these days. The pulling seems to flatten the weld a bit more, and that's sort of how they get that real nice rolled weld. I don't like it, not the weld look, I don't like how you do it, because even if I do it myself, and I know people might say you can do it without the issue, I've cut into it many times and spent a lot of time on settings. It still has a cratery area where it basically is not penetrating correctly. And I get that if you welded this whole thing out, there's enough weld there that it probably will never have an issue. But I just don't believe it's a great weld. That's my 2 cents. The world that comes around welding and online, holy shit, it is such a vulnerable place to be. But, you know, you just have your thoughts on things, and that's basically where I'm at. So I do push, and I do get that kind of look by just pushing. And when you watch it, you can, it's just cursive ease, which is not a horrible practice by any means. I think the pulling and watching it fall back down into itself, I think that's where the V inside the fillet is not getting it crucial, like, you know, enough. Because I tell you right now, if you're trying to do a weld on the outside corner of this and pull it, the settings will be down pretty low so that it falls in there and it's not an issue. Now, if you pull that, I'll tell you right now, that is a fucking cold weld in there. And I guarantee if you cut it open, it's not going to do fucking jack shit. That's just where I'm at with that. So I like to push the weld. I do cursive ease like that there. I don't do a great deal of MIGging at the moment. So, you know, not like one of these guys that sit in a shop all day and just lay down MIG welds all day, or aluminium welds, or stainless welds. And that's where I think it's good to not be judgmental on yourself too, especially people at home doing this kind of stuff. You're not doing this day in, day out. You're not doing one practice day in, day out. And I think a lot of the people that judge these days are people that sit on a rotator and weld out something that's in a fixed state and fixed amps, or they sit in a shop and weld out this kind of shit and they'll weld it day in, day out. Now, I would say I'd launch you to be pretty damn good at it. And I guess for the people at home that beat themselves up sometimes, it's not your day job. You're not doing it all the time. So, you know, don't beat yourself up too hard. Anyway, I'm going to go through, I'm going to weld this out. Got a bit of Lincoln anti-splatter here. With this wire, honestly, it does burn very nice, and you don't have to have much anti-splatter on it. I'll tell you, one anti-splatter to avoid is Unimig. That shit is horrible. It's like a film that goes on there. It's gross. You got to clean it, all this kind of stuff. This stuff's pretty good. A lot of people make their own anti-splatter too that do this too. So we're going to go through and lay down some welds, 2 different settings which will go between here. This is going to be a lot hotter on the base and everything that we're doing to get this to thicken up that weld in the fillet. On the edges here, we will come down a little bit on the bolts and try and, you know, just cap that in. But like I said, this will all be pushed. So you will get a bit more proud of a weld in the middle from pushing versus the pull, because the pull, you're pulling the arc along and it's like pulling the hot along. It's like stick welding basically nearly. When you're pushing it, you're sort of bringing that cap up, and that's sort of the best I can explain it. Anyway, we'll shoot in and pretty much just weld all these out and get ready to slap them on the chassis. Just finished letting the contraction process of the actual mount fully cool down, and that was basically to let that bung fall out once it had finished in that process. Now we've got it sort of semi-mocked up on the side of the chassis where we picked off the old one, and this one will sort of set the one on the other side. We do have to do a bit of a modification on a bit of sheet metal underneath the car on the other side. It was just a matter of, we need the bracket X amount of size and where we had the location of it. So we will touch a little bit over there and should all fit immaculate. So what our plan is now is basically go through and put some tacks on the spots and follow it with the clamps. This midsection at the moment is pretty good and tight. So I'll go through, put some tacks on it, and then what we're gonna do is pretty much float one of our arms in there, chuck a King's coil in there, and just sort of, you know, visualize it a bit, I guess. Sort of get a bit of an idea of what we're dealing with and how it sort of looks. I'm actually pretty excited too, because I reckon it's gonna look fat for a Defender. Got down a little heat mat here, just sort of protect anything while I'm doing some spot welding here. These little puppies are just a fire blanket. They're like $8 from Bunnings. I've got tons of them, and they're just really good for putting in small little spots. Throw them in a bin and get another one. The welding blankets, they're good, but a bit expensive, and also too, this just does the job, you know? So, pretty good there. Now, mind you, I've done this a fair bit, so I am closing my eyes before we do lay down the bead, or the tack, if you want to call it that. So we're pretty good there, that's in there. Happy days. Take this clamp off. And it's just a bit of a process really, once you start to move around the vehicle and that. We know that the front section's all good. I just got to bring it in with these clamps once we get to that point. But pretty well, you want to get it nice and tight on the chassis. Otherwise, as you're welding, you'll be trying to weld in between this little seam. So just make sure too, like I said, top to bottom, because chassis generally got a bit of a bow in the middle on that, it's going to try and take the last point that you welded. So we're pulling in a little bit there. That's nice. Righto. Happy days. We got one more here. Righto. And like I said, it's a bit of a process, but don't be impatient, otherwise they'll come back to get you, especially when you're trying to weld the little pads in the middle here. Just going to bring this up a little bit, chuck it up to about 10 and 22 here, 22.5, get a bit hotter. Tack, 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 tack. All right. This axle's only just floating here at the moment. The pinion's sort of folded down until we support it in the spot that we want it. Don't go crazy either. If you've got to pull it in a lot, you're probably most likely pulling in the back of the chassis. I dare say by tomorrow, it's going to look like I just come back from my bizzer. Nice tan on the face. All right, this should be pretty much get us home on the front here. Bring that teardrop in. Now you're probably asking the shape and stuff like that. This is to help with the structural, plating of this chassis. For people external in New South Wales, obviously there's builders codes and stuff like that, but the radius and stuff like that, which alleviates cracking, and the way that they ask you to do it in the actual chassis building modifications for trucks and stuff like that, it's sort of where you get most of this from. And it's the same with welding on chassis. You don't want to weld down. Obviously some welds on cars and stuff like that have to be that way, and that's like OEM spec stuff, but try to avoid it because it is a prone area to cracking. I tell you, as I get older, I do not enjoy being under cars that much anymore. I think I've done it enough now that it's starting to wear a little bit thin. Alright, that's a good little spot there. So like I said, we're just trying to pull this in. Yeah, nice little spot on that. Another one up here. Oof, that is not bad. I'm pretty happy with that. All right, juicy tack. You get one on the front just because that is holding down a bit. Nice, that's what we wanted. All right, now crack this one back out. Just want to get one right here. And I think that should do us. Yeah, that's it. Now, you're probably seeing this from the other angle, but this mount is quite close to the car, and lucky this is a single cab, but I will be jacking the back of this car up a little bit, and we do have to bring new mounts and stuff like that in anyway because we have taken it off here. This structure was all wrecked, so what we are going to do is basically build some new structure along the top here, which will probably tie into our coilover towers and stuff like that. But I wanted beef, and this is where we're going to put it. So we'll just bring it up a little bit, and we'll get that top weld, bring the cab back down. Happy days. Pretty easy stuff, really. All right, so what we're going to do now is I reckon we get a link in, eh? We've just pulled out our little slug in here. This was in for the welding process, just to keep the uni ball cup concentrically round while we weld it out. They are a bit of a pain, especially with the uni balls and stuff like that. Generally the uni ball that come with the cup I try and keep with it, but I don't know, some of them seem to be a little bit iffy these days. Alright, put this little circlip back in. This can be a pain too. Oh, that's the spot. Alright, now we need to get that nice and parallel so that we're not fighting anything here.
Where we at? Oh, that's pretty good. Pretty happy there. All right. Got our bolt, got our nut. Let's get it in, eh? These things are fucking heavy too. Ooh, come on. Now I'll set up a little jack here to try and cheat. Oh my lord. Alright. Hopefully. Oh, we're looking good, boys. There's that little hole. Ooh. Alright, a little twist. Gotta get the other side over here now. Because that uni ball doesn't move around and all that stuff. There we go. That wasn't so bad, was it? Got a little washer dog in there. I'll just chuck this on for now. This is a non-locking nut just because we don't want to put a permanent one in there yet. Just for mock-up. Chuck that home there. This is where it comes in with doing stuff right and taking the time and all that. And I know I harp on about it, but you know, I do this stuff on camera while I'm going, and you can see that it just works out. All right, so where are we here? Axle. Let's say we're probably going to come up a little bit. This is probably a bit of a bad idea, but there we go. How's that looking? Now we set about 5 degrees, about there. Juicy. Righto. And then we've got little tabs here. Now I'm not 100% sure if we're going to use these yet. Just sort of had them laying on the shelf. They are sexy. Nice little billet 10 mils. Obviously when you do this stuff, make sure your orientations so you can get your bolt out still. Go like that, on there. All right. That nut wants to go on. Now, like I said, we're only just temporary mock-up at the moment. I'll remove this little stub here. Oh, Jesus. This isn't like X-rated. Holy Josh. Is this loose? Oh. This is pretty exciting stuff, guys. What do we got here? Go through and chuck some masking tape on these. We don't want to ruin them. But at the moment we're being pretty gentle. Alright. You don't want to flare off the side here. How about we go back like this so you fall into the cab. There we go. Okay. You want to sit there and this be nice? There we go. Okay. We give it a bit of shaft. What do you reckon? Ooh.
That's what she said.
Pull it here. Probably say that's. Now with these bottom coil caps, they actually do seat the shock inside here, so you do have about 1/2 inch that does go in there, but I wouldn't use that. I'd use that as a protection area and have my stops to stop that. Put this. No. Go like that. There we go. Probably take that off in a second, actually. But holy, how is that for a Defender? I don't see many like that. So, this is going to work out very nice. And also too, like I said, very minimal amount is going to protrude up here, if any, depending how we do this little section. Like I said, we've only got about 5 inches of up travel, but that there
doesn't relate. So 5 inches of up travel there might only be 4 inches here or 3.5 or something. So pretty cool with that in terms of bringing these down versus mounting them in the middle and having so much excess come up. And also, like I said, in most circumstances, the chassis would be wider, so your footprint on the stability of those shocks mounting wouldn't be as great as what we do have here. I'll be honest with you, that they're pretty nice, so I'm probably going to keep them. And we'll just do a nice little cap, and we'll roll that into our little section there for our bump stops. Yeah, that is juicy. Well, I think next now is going to be working on the other side. Like I said, a little bit of trimming I got to do. And once we've done that, this is probably going to be tack the lowers in so that the diff is sitting there with our pinion all nice. Then once we know that locked in section there, pretty well we'll go and start designing a forelink. So we'll go back into the computer, all the fun stuff, and do some design in there. And once I'm sort of done with that, we'll shoot back out, get some hydros in, get some uppers in there, so some 70-75, probably 50.8 mil links, and we'll chuck our rod ends on, do our triangulation factors and all that stuff and calculations, and I will show you what that data sheet looks like. We'll manipulate it to try and execute or mitigate as much roll steer as we possibly can, and obviously help with our anti-squat and see what those factors are for this particular vehicle. So we'll go through and chuck some more of this in, and you'll probably catch us on the forelink video.